Welcome to Chem Help ASAP. Let's talk about the similarities and differences between the mathematical models of enzyme and receptor action. On the screen to the left, we have the mathematical relationship between E over Emax and ligand concentration. This is Clark's occupancy theory, which is a model specifically for receptor response. I have the same equation rearranged just a bit. So the idea is that a ligand binds to a receptor and some kind of response is the result. To the right, we now have the Michaelis-Menten equation for the rate of an enzyme catalyzed reaction based on substrate concentration. Well, these equations are strikingly similar. Functionally, in an enzyme, a substrate binds and then a chemical reaction occurs. These two systems look the same. One thing binds and then something happens. The Michaelis-Menten model is very robust for many enzymes, but receptors often violate the simple Clark model. Here are some key ideas about receptors that cause them to violate the simple model of occupancy theory. First, some receptors can be turned on without being bound to a ligand. This is called constitutive activity, and means that the receptor can be active without ligand occupancy. In contrast, an enzyme cannot convert substrate to product without being bound to a substrate. Our second consideration is that different tissues can have different levels of receptor expression. So you might have higher expression of a receptor in smooth muscle tissue than skeletal muscle tissue, and the effects or responses seen in each tissue might be different. Lastly, different ligands have different abilities to affect the receptor. This idea is called intrinsic efficacy or intrinsic activity, which changes for each ligand-receptor relationship. With all these factors in mind, this simple occupancy model shown on the left changes into the more complex equation on the right. The E-naught variable accommodates the idea of constitutive activity. We also have a new term for the receptor concentration to address different receptor concentrations across different tissues. Finally, the Greek letter eta takes into account the intrinsic activity of a ligand. So we have Clark's simple model on the left. Different scientists, Ariens, Stephenson, and others have modified the simple equation to better fit data sets that are not well modeled by the simple relationship. The Michaelis-Menten equation does not have an analogous expanded form. So this equation to the bottom right highlights the higher complexity of receptor-ligand relationships. While enzymes and receptors do have similarities, receptors have many more potential nuances. The models, therefore, can be more complicated. Please like, subscribe, or leave a comment. Take care.